We have question 3 from a November 2016 exam paper. So, question 3 reads as follows: a ball is dropped from the top of a building 20 meters high. Ignore the effects of air resistance. So, because we know that the object, or more specifically, the ball, was dropped, we therefore know that the velocity of this object when it was dropped is 0 meters per second. It is important to note that whenever an object is dropped or released, it has a velocity of 0 meters per second. If it is projected or thrown, then it has a velocity. So we know that this object was dropped, and if this object were to hit the ground, that means that the displacement that this object traveled would be 20 meters. Now, for all my calculations, I'm going to take upwards as positive. So my first question, question 3.1, define the term free fall. So free fall is defined as the motion of an object that is under the influence of gravitational force only, or you can use the word gravity instead of gravitational force. So basically what that means is that after this object has been thrown or released, the only force that is acting on this object is gravity. There's no applied force, there's no tensional force, there's no normal force. The only force acting on it is gravity. And gravity always acts downwards, irrespective of whether the ball is thrown or the object is thrown upwards, downwards, left, or right. Gravity always acts downwards. If we were to draw a free body diagram of this object, this is what it would look like. And we'd only have one force, which would be gravitational force. So, our next question, question 3.2, calculate the speed at which the ball hits the ground. Now, for this, I'm going to take this as my initial point, which is where the object was dropped, and I'm going to take this as my final point, which is where the object hits the ground. So, after a distance of 20 meters, this ball will then hit the ground. And because I am moving, or because the ball is moving in a downwards direction, and I took upwards as positive, that means the final velocity of this object is going to be negative. So let's try and see what values we have. We have the initial velocity at this point as 0. We want to calculate the final velocity at this point, and we have our value of A, which is negative 9.8. Now, the reason that it's negative and not positive 9.8 is because gravitational acceleration, or gravity, is downwards, whereas I have taken upwards as positive. Therefore, my value of A is going to be negative. Now, my displacement. How do we know whether displacement is going to be positive or negative? Now, if we were to draw a vector of our displacement will be a 20-meter arrow going downwards because the object is moving downwards. And I took upwards as positive. Therefore, my displacement will be negative 20. If the object was thrown upwards and we only took a small section of that displacement, let's say, for example, this object was thrown upwards, and we only want the displacement until its maximum height. If we were taking that part into consideration, then my displacement would be positive because it's moving upwards. the arrow or vector of that displacement would be this. But because my displacement, or because the object is moving downwards and it's going to be a 20-meter vector, I know that my displacement is negative 20. There's a different way that we can calculate displacement as well. So we can have displacement as delta y equals our final position minus our initial position. Now, our initial position is the height at which the object was dropped. Our final position is the height at which the object hits the ground. Now, we know that when our object hits the ground, it's 0 meters above the ground because it's on the ground. And when the object is dropped, it is dropped from a height of 20 meters. Therefore, our displacement is going to be our final position, which is 0, minus the initial position, which is 20. And that is therefore equal to negative 20 meters. So you can use the vector method or you can use the calculation method. That is completely up to you. Some people might find it easier to use the calculation method, whereby you just put in the final position minus the initial position and you'll get your positive or negative sign of your displacement. It is very important to substitute the correct sign because that can affect your final answer. So one more important thing is that our value of A is negative 9,8 meters per second squared. Now, let's substitute that into a formula. So we have our acceleration, we have our displacement, we have our initial velocity, we need to find final velocity. So which formula are we going to use? We have four. Our first is Vf equals Vi plus A delta t. Our second is Vf squared equals Vi squared plus 2A delta y. Our third formula is delta y equals Vi delta t plus 1 over 2A delta t squared. And lastly, we have delta y equals a half into Vi plus Vf delta t. So let's try and figure out which formula are we going to use. So let's have a look at our first formula. We have Vf equals Vi plus A delta t. We are looking for Vf. We have Vi, we have A, but we do not have time, so we cannot use our first formula. So let's put it aside in case we might need to use our formulas later on. That way I don't need to rewrite them. Now, let's have a look at our second formula. So we are looking for Vf, we have Vi, we have acceleration, and we have displacement. So I can use my second formula. Let's look at our third and fourth formulas. So if we look at them, we can see that we need time for these formulas. And time is a value or a quantity that we do not currently have, so we will not use these three formulas. So let's keep that aside. So how do we figure out what formula we need? We can list our four formulas, or we can look at our formula sheet at the back of our exam paper, try and identify what do we have and what we don't have. If you don't have a quantity, chances are you can't use that formula. Alternatively, if you have to use the formula, or if you want to use the formula even though you don't have that value, you would have to use another formula to calculate for that value and then use that formula. But I feel that it's best to just check which values you have and which values you don't. That way, you can use the formula whereby you have all of the values except the value that you were trying to calculate for. So let us try and substitute. So we can bring down Vf squared since we don't have that value. We can substitute Vi as 0. Don't forget to square it. Plus 2 into negative 9 comma 8 into negative 20. Now, from here, we can put all of this into our calculator. So, on your calculator, you can put 0 squared plus 2 times negative 9.8 times negative 20. And that'll give you a value of positive 392. Now, if we put in the incorrect sign for displacement, for example, if we put in positive 20, we would have ended up with a negative value of 392. And we know that we can't square root a negative value because it's going to give us an error and we would have been stuck. So that is why it is important to make sure and to double check that your signs are correct. Now, let's move on. From this point, we can square root both sides, and our value of Vf will then be the square root of 392, which is 19.8. But keep in mind this is positive or negative 19.8 because whenever we square root a value, it's always positive or negative. Now, the next part is up to us. We need to decide, is our value of Vf going to be positive or is it going to be negative? Now, because we know that our final velocity is in a downwards direction because our ball was dropped and the velocity before it hit the ground was going downwards, our object was going downwards, and I took upwards as positive, that means we need to take the negative value. So our velocity is going to be negative 19.8. So we can conclude that therefore the final velocity of this object is going to be 19.80 meters per second downwards. So that negative sign just represents that it's going downwards. Now, the reason I like to put in that negative sign before my final answer is because if I need to use that final velocity value later on in another question, I know that I have it there. I won't just look at the final answer and see a positive value and substitute a positive value because that would be wrong. It's actually a negative value. So that is why I like to keep the negative value and then write a final answer. So our next question, 3.2.2, calculate the time it takes the ball to reach the ground. So we need to find out how long does it take this ball to travel a distance of 20 meters from the top of the building until it hits the ground. So we need a formula that has time in it. So I'm going to use the first formula that we had. Okay, now let us substitute. So our value Vf is negative 19.80. Our initial velocity is 0 plus our value of A is negative 9.8 and delta t. That is the value that we are looking for. So from here we have negative 19.80 equals negative 9.8 times delta t. So from here, we can divide both sides by negative 9.8, and we will therefore have a value of 2, comma 02. So it takes this object 2, comma 02 seconds to go from a 20-meter high building until the ground. Now, our last question is question 3.3. Sketch a velocity versus time graph for the motion of the ball. We do not need to include any values. So our first option, or our first step rather, would be to decide which quadrant this graph is going to be in. So we know that time is in the x-axis, whereas velocity is in the y-axis. And time is always going to be positive, whereas velocity can be either positive or negative. So we need to decide whether it's going to be in quadrant 1 or quadrant 4, because time is only positive, or the x-axis is only positive in quadrant 1 or quadrant 4. So because we are dealing with negative velocity values, because we had 0 and negative 19.8, we are going to go with the quadrant that gives us a negative y-axis, which is quadrant 4. So we are now going to sketch a velocity versus time graph, and it is going to be within quadrant 4. So we put in our time and the unit that time is measured in, as well as velocity and the unit that velocity is measured in. Now, we are not allowed to include values, but to make life easier for ourselves, we can include them and just erase them afterwards. So let's look at our initial velocity and our initial time. So we can use a coordinate system because that is something that we are used to from math functions. So we know that initial time is our x-axis, and initial velocity will be on our y-axis. So time will be x, velocity will be y. So we know that the initial time is 0, and our initial velocity is the velocity at which the object was dropped. So that is going to be 0 as well. So our first coordinate is going to be 0 and 0. Now, our second coordinate, our ending point, is going to be our final time, which is 2, 02, and our final velocity, which is negative 19,8. So negative 19,8 is almost negative 20. So that's a bit low in our y-axis. So if we have negative 20 as somewhere here and our value of 2 somewhere here, that'll mean our ending, or our coordinate, will be about here. Whereas our 0 and 0 is our origin, which will be about there. So all we need to do is draw a line that is moving in the positive x-axis and the negative y-axis. So as this moves in the bigger x-axis, it is moving in the smaller y-axis. Or the easier method would have just been to plot out two coordinates and then erase them afterwards. So now, because we know the general direction of our line and we do not need to include any values, all we can do is make two random points in the general direction of our line and plot them or connect them. So that's our first point. Let's make our second point somewhere here, and let us connect these 2 points. So all this line shows is that as time goes on or as time progresses, this object goes into the negative velocity area, or its velocity gets bigger. And that is our last question of this 2016 exam paper.